so remember this is the last one we looked at. It was our P of X, so it was slightly different because we were just looking at profit, and so we didn't have a geometric figure, so I didn't have to draw a picture. Also, because when we created our equation, we just had one variable, we also didn't need a secondary equation, so that was kind of nice. We have one last one. So it says the new Thunder Arena is being built. One side of the building has already been built. The arena must contain 245,000 square feet in order to be large enough. What should the dimensions of the 3 remaining sides be so that the least amount of material is used? So what do we want to do first?
Read it carefully.
Cool. What do I know?
One side is already built.
Ah, okay. Which makes sense because it only asks for dimensions of the other 3 sides, right? So that's going to be important. Do we know anything else?
It has to contain 245,000 square meters.
Okay. And then what are we optimizing? Material, yeah, and we want the least amount, yes? Okay. Then what's next up? Draw a diagram. Alright, so we already have one wall built. We then have to build the other, we're assuming it's a rectangle, okay? The other 3 sides. Yes? What do we want to label those?
X and Y.
Sure. X and Y. Alright, then what do we want to do next? You should have your handout from Friday that had our list of stuff.
You have an extra copy of that?
What comes next?
The objective function.
Hmm?
The objective function.
Yeah, make our objective function. So what are we trying to optimize? Material, right? And we're just looking at the material for the walls, right? So what would an equation be for the material for the walls?
2x plus 2y.
So you're looking at
The perimeter.
the perimeter, okay? I agree with that. I don't agree with your equation. It was part of it. Ah, why do I only have one y?
All the walls is already built.
Ah, because one of our walls is already built, and we are only looking for the 3 remaining sides. Agreed? So right now I have 2 variables in my equation. I don't want to take the derivative with that. So do I have any other information?
The area.
The area, okay. So what's our area going to equal?
245,000.
Yeah, sorry. What's the equation of our area equal?
X times y.
Yeah. And then yes, that equals 245,000. So then we can solve for one of those. Which one do we want to solve for?
X.
Sure. Yes? So I get x equals 245,000 divided by y. Then what do I do with that?
Plug it in.
Where?
Perimeter.
Yeah. Into our other equation. So we have P equals 2 times 245,000 divided by y. That's a bad y. Okay. So then we probably want to simplify it just a little bit. What is 2 times 245,000?
490,000.
Yes. Alright. Then can we take the derivative of that? Right, because the next step, take the derivative. It's pretty much simplified as much as it's going to be. 490,000 over y.
490,000 to the one other one.
What did you
Or
say?
wait, what? Never mind, no.
Okay.
490,000 times y.
Yeah, so if I have y to the negative first, what's the derivative of that?
Negative y to the negative second.
Cool, which is the same thing as having,
Negative y squared.
yeah,
Negative 1 of y squared.
negative. So the y squared is on
The bottom.
bottom, yeah. So, gonna add in the negative. And then now this is over y squared. And then what's the derivative of y?
1.
Just 1. Okay, so we have our derivative. Then what is our goal after that?
So equals 0.
Y.
So you can find the critical point.
Yeah, we're looking for our critical values. How would we solve that?
Add 1 to the other side.
Opposite of that.
Subtract 1 to the other side.
There you go. I'm going to subtract 1 and then I would multiply by
Y squared.
y squared. Then I would divide by a negative and take the square root. What do we get if I take the square root of 490,000? What's the square root of
700.
49? 7. And then if I have 4 zeros, that means that the square root has to have 2 zeros. So we should get plus or minus 700. But we are talking about dimensions, so we really only care about the positive one. Yes, no, maybe. Then what's the last thing that we need to double check?
It changes signs. Okay.
What is it?
The function.
No, not the function.
The derivative.
The derivative, right? Because my derivative is what has to change from increasing to decreasing or decreasing to increasing. So I need my derivative to change signs. So what is something that is before 700 but bigger than 0?
1.
Sure. We plug that into our derivative function. We just get negative 490,000, right? Divided by 1 is still itself. Plus 1 is that going to be positive or negative?
Very negative.
Very negative. Well, that's good. What is something that's bigger than 700?
1,000.
1,000. Sure. If I square 1,000, is that going to be bigger than 490,000?
Yeah.
Yes, which means that this fraction is going to be,
Negative.
well, it's always negative because I have a negative there.
Smaller than 1.
Smaller than 1, right? If the bottom is bigger than the top, then we have a fraction that is smaller than 1, which is important because then I'm adding that to 1. So if I have a negative fraction that's smaller than 1 and I add 1, we still have what?
Positive.
Positive. Which is good because if I'm going from negative to positive, so if our derivative is negative, what does that mean about our original function?
That's a negative slope.
Yeah, we would also call that what?
Decrease. Decrease.
Decreasing, yes? Then after 700, we turn to go,
Upwards.
or in other words, we call that
Increase.
increasing. Okay. So what has to happen at 700 then?
Turning point.
Okay, specifically what kind?
Critical point.
Not quite.
Minimum.
Minimum, right?
Right.
Which is what we want because we wanted the least amount. Yes, so it makes sense that we should have a minimum there. Then what's the last thing that we need to find?
What x equals?
What x equals? So x equals 245,000 divided by y. So what is 245,000 divided by 700?
$350.
So that should be how we feel about optimization. Okay? We kind of talked about, like, none of the steps in and of themselves are hard, right? Because it's a lot of geometry, which most of us are fairly okay with. And then it's just our basic finding the derivative, setting equal to 0 step. It's just the initial kind of deciphering of all of the words and then remembering all the steps that you have to do.